All right, if you've ever touched data in Python, you know the feeling. Raw data can be, well, a total mess, right? Just a jumble of lists and dictionaries. Today, we're going to demystify all that. We're going to take that chaos and turn it into clean, beautiful, structured tables using the absolute workhorse of data science, the Pandas DataFrame. A lot of the time, your data starts out looking something like this, just a cloud of disconnected points. The real power, the real analysis, only happens when we can give it some order. So the big question is, how do we get from this messy cloud to a perfect grid that we can actually use? And the answer is the Pandas DataFrame. You can think of this as the central engine for pretty much all data work in Python. It's the foundation. Seriously, before you can do any cool analysis or make a fancy visualization or export your results, you have to get your data into a data frame. It is the absolute, non-negotiable first step.
So, before we jump into building one, let's just quickly look at the blueprint. What exactly is this grid we keep talking about?
At its heart, a data frame is just a rigid, two-dimensional table. And rigid is really the key word here. This isn't just some loose collection of information, it's a superstructured format, almost exactly like a spreadsheet, but way more powerful. And this right here perfectly shows our goal. We're taking that initial chaos and mapping it onto this precise grid. The vertical columns, those are your features, things like name, age, or price. And the horizontal rows, each one represents a single record. Every single data point now has a specific address, right at the intersection of a column and a row. No more chaos. Now, here's the cool part. Pandas gives us two main paths to build this grid from our raw Python data. We're going to walk through both because choosing the right one really depends on how your original data is shaped. Okay, first up, let's talk about Path A, building from a dictionary of lists. This is probably the most common way you'll see it done, and its whole logic is built around columns. The logic here is really intuitive. It's totally column-centric. You start with a regular Python dictionary, the dictionary's key that automatically becomes your column's name, and the list of values that goes with that key that just fills in all the rows right underneath it. It's a very direct, very clean translation.
Let's look at a perfect example. We've got this shopping dictionary. You see the keys are Ajay and Dia. The moment we feed this thing into Pandas.DataFrame, boom, the keys instantly become our column headers, and their shopping lists just neatly fall into place in the rows below. It's a perfect one-to-one map.
Okay, but what if your data isn't organized by columns? What if it's organized by rows? Well, that brings us to Path B, the list of lists method. This approach is all about the rows. You start with a big list, and then each list inside of it represents one single complete row. But here's the catch, and it's a big one. Lists don't have keys like dictionaries do, right? So there's no automatic way to name the columns. We have to tell Pandas what to call them ourselves.
So here's our shopping data again, but this time it's formatted as a list of lists. To get this into a proper table, we passed it to the data frame, but with one absolutely critical addition, the columns argument. See that? This is where we manually give it the list of headers, Ajay and Dia, to inject that essential structure into the raw data.
So there we have it, two totally different paths that get us to the exact same goal. So the obvious next question is, which one should you use and when? Let's break it down.
And this is the real aha moment. Just look at this. We started with two completely different Python data types, a dictionary of lists and a list of lists, but the final data frame we get is identical. This is the magic of Pandas. It handles that messy conversion for you, abstracting it all away so you get a clean, predictable table to work with no matter where you started.
So which one do you pick? This table makes it pretty simple. Is your data already grouped by features, like all the names are in one list, all the ages are in another? Use a dictionary of lists. You get automatic column names for free. But is your data organized in rows, like you're reading a file line by line? Then a list of lists is definitely the way to go. This isn't just theory, it's a really core practical skill. In fact, a super common assignment for students learning data analysis is to do exactly what we just did. Take a data set, build a data frame one way using the dictionary method, and then build the exact same table using the list method. It's the perfect way to prove that you really understand both data orientations. And to help you on your way, here's a handy little reference card. Think of it as your data blueprint. On the left, you've got the syntax for the column-centric dictionary of lists method, and on the right, the row-centric list of lists method with that all-important columns argument. Definitely keep this one nearby for your next project. And that's really it. You now have the blueprint for turning raw, messy Python data into a powerful, structured Pandas data frame. You know the two main paths to get there, and you know when to use each one. So the only question left is, what are you going to build first?